In part 3 of our modelling fundamentals, we're going to have a look at the ProSteel workframe, and we're going to start putting in some steel work. Now, I'm going to kick off by saying we don't need to use a workframe. You don't have to use a workframe. ProSteel will quite happily allow you to model shapes and objects just in space, free form as such. But I find that the workframe is a really handy tool for just being able to flesh out the views and give us stuff to snap to and so forth, to give us some boundaries. So we'll kick off on that. So this is where we left off for part 2. And one thing that I'd like you to know is if I select, which is left mouse button, pick, and right click and hold the right mouse button down, I have the option for any ProSteel object to go into its properties, or quite often to edit it or delete it. So in this instance, I do want to delete it, but it's very important that you remember, if you want to edit an object later, just simply select the object and hold down right click. So I'm going to add the workframe, which is in the ProStructures dialog. You can see down the bottom left, enter the origin of the workframe or reset for the ACS origin. So reset is right mouse. Again, read the command line, enter the x-axis of the workframe or reset to use the global x-axis. So it's just reset again. So right click, right click. Simple as that. It will come up with the basis of a workframe for you. This is the default one in the Australian localization. Okay, we have several different types of workframe that we can have. Okay, but the rectangular one here is the most common one. You can set your length, which is at the moment set 3 grids over 20 meters, or 20 meters broken into 3 grids. Okay, and you can see that the number beside length applies to the graphic. So we have 3 grids, 1, 2, and 3. Okay, the width is 10 meters broken into 2 grids, being 1 and 2. So if we added a third, it would add a third right in the middle. Okay, and the height is broken into 2. We also have our insert position, so we can toggle that around just to lay out how we want this to be set from 0. Okay. We have a roof angle, which is number 4, currently set at 8 degrees. The ridge height as an option to the roof. And the ridge width. Now the width would normally be half, for a normal apex, would normally be half of number 2. Okay, the ridge width would be half of number 2. If we set it to 0, you can see it makes a skillion. If we set it to 10 meters, it'll push it the other way. Okay, if we set it to 0, it would have nothing. Okay, nice and friendly. Very easy to follow. All right. If I broke this down and say 4 meters into 2, like so, this is actually what we're going to work with a little bit later. 3 meters in height. You can see we end up with a little cube. Okay. It all works on the fly, updates as you go. All right. While I'm here, OK means take the settings and apply it. Cancel means cancel everything. Help will take you out to the PDF help. Templates, if you ever get yourself in trouble, come to the templates. I've tried to give you a template for almost everything. So you can see here, if I go to a workframe, I've got a couple of different options. I can right click and go load my template. I can double click on it, or I can highlight it and then come up to load. So there's 3 different ways that I can load the one template. Okay, that will take us back to the default. So if you ever get yourself in trouble and you think, oh my goodness, what do I do to get out of here? How did I get myself to here? This is not what I'm after. Just set it back to the base template. So I'm just going to set this back to the settings that we had before. 4 meters by 4 meters by 3 meters high, little cube. Okay, while I think of it, this show illustration is invaluable while you're learning, because what it does is it lines up the numbers down the side with the graphic, which makes a lot more sense while you're trying to learn what it is that it's asking you, particularly in complex connections and so forth. The other thing I'd like to point out is in every dialog, the Layout tab, okay, the first tab is the general length by width, okay, of the connection or whatever it is, and after that, everything here is the specifics. Okay, you get into the specifics of the dialog or the connection or whatever. Okay, now in the Views tab, we have the clipping plane distances set by default at 500, which means you won't see any steel further than 500 away. I like having my height dimensions with coordinates set. The update connected shapes will update if your workframe updates. This is a little bit of a dangerous one, okay? And my user-defined X and Y allows me to define my own X and Y should I want to. Okay, text in the X direction is the global X direction, currently set to numerical, okay, which means that your text in the Y would normally be set to alphabetical, okay, by default. The text in the bubbles, okay, we can just have normal text. I can have it rectangular, I can have it a block. By default is circular, okay. The connection line is actually the little line that connects your workframe up to the bubble. You can see I'll just toggle it on and off here. Okay. We have our descending, which will flip the 1 and 2 over there. So it goes, 2, 1. I can ignore the first axis, ignore the last axis. You would use this in an instance where maybe where one axis is a long, long way away and you just want to shrink everything down, or alternatively you could turn it off for an existing building. Dynamics simply flips the bubbles up to the current view and will follow the current view around. Okay, and back will push the bubbles over the back side just to clear some steel or something like that if it was over the top or something. Right. The start value is the value that it will start at. So if I changed it to 9, it'll start at 9 and go to 10 as an example. All right, the main axis will put a prefix on it. So A1, A2, etc. You can see it's really flexible in here. Lots and lots of options. And two lines, the 2 line switch there will, instead of put it side by side, it'll put it on top of each other. Okay. The distance is the distance, how close it is to the main workframe body. All right. And the key thing here, this is really paramount. That is the text size. The 3 mil size is the text size in the bubble at any given scale of any border that you put it on. It'll always be 3 mil. If you need to change the size because you can't read it, change it in the options text scale. That is only relevant in this drawing or this model. Okay, never change it here. Okay, because what it'll do is if you change it to 10 or something, it will be 10 times the drawing scale. Okay, where that's 3 mil high. All right, the key thing is to remember, try and make X and Y about the same. The only difference is the left, as an example, instead of front back, you've got left to right. Border lines is for putting your own border, your own grid lines in. Okay, and that goes hand in hand with the individual editing of the axes. So if I wanted to change the axes label to, for a piece of machinery or something, I could have 1.5, okay, and then that will update. It's a manual one. All right, nice and simple. To set it back, you can just remove the X, or we can just overwrite and reset the main axis back to 1. Okay, hopefully we've got all that. Final thing is our options. Key thing within our options to, I guess, remember, -1 would be the default configuration. You can see here I've defined colors. Our text scale, things to remember is don't forget your text scale. the line type, okay, is center 2, and that is for the main grid. And your text style is standard. Really important here, don't change that from standard. Wherever you've got an example to use text style, okay, set it up in your main settings for your text. All right, if you want to change standard, you can see in my text styles here, my standard is Arial. Okay, so if I wanted to change it to, ISO, something like that, I would change it here and it would go right through the model. Okay, so don't change the text style here, keep it standard. All right, final thing is axis names on edge. Please don't ever switch that on. Okay, it makes a real mess. It throws the bubbles right out on the edge of your border, and sometimes you lose them because if you scroll right out, they disappear. Okay, just want you to remember, if I want to come back in here, select, right click, and it brings us back right back into the last dialog we used for this. So let's add a second work frame now, but instead of 0, 0, 0, let's go B on grid B1, and I'm just going to go reset to maintain the global X. So I've picked a point this time and gone reset, and it's used exactly the same settings as I had before. So we have 2 work frames exactly the same. Now, it's not a realistic expectation to expect our grids to be fully symmetrical. So how do we go about non-symmetrical work frames? Well, that's really easy. If you have a look on the left-hand side of their length, width, etc., we get a checkbox here. Okay? If we untick that, the left-hand side grays out and the right-hand side gets enabled, and we can actually put our own work frame dimensions within here, our grid centers within here. So I can have 2 grids at 4 meter centers as an example. Okay, it works very nicely. All right, we change our height. Our height, instead of being 1 at 3 meters, I can make the first one 3 meters and the second one 3 meters, and just select another box here somewhere, and it'll update. All very nice. So that's what we need. Now, what happens if we've got, one of the things to watch out for is if at the moment we keep filling these out, but one of them is, a very narrow one. I've got standard 4 meter grids, and one of these is short, like 2.5 meters. Just be careful, check your work. If I put one in at 2.5 meters as an example, check it's on the right end that you not want it on. You don't want to fill out 15 grids only to work out that you've put them in back to front. Okay, so it's just check your work as you go. Don't just assume it's right as you're typing centers in. Okay? All right. So I'm pretty happy with all that. Let's run with that. Now, one of the things you probably notice, see how the grids are over the top of each other here. Let's tidy this up. So if we have a look here at our alphabetical, we've got A, B, A, B, because it was 2 work frames exactly the same, when it really should be A, B, B, C. Okay? So really, grid work frame number 2 really should start at B. So there we go. So A, B, B, C. And that there's just 2 B's over the top of each other there. So it won't affect anything, won't give us any trouble. The other thing too, really, let's push these over the back. Okay? So these are the numerical ones, and flick that. And you can see it presents a lot nicer. Okay? Really user-friendly. I really like work frames. I use them as much as I can. All right? One of the things to watch out for, they're a little bit hard to see sometimes in the wireframe. They stand out, sorry, not in the wireframe, in the transparent. They stand out a lot more in the wireframe, but I mean, really, we're in a 3D modeling package here, so we might as well leave it transparent modeling. It's just a little bit harder to see, that's all. All right, let's jump in and put some steel work within here. Okay. This is the basis of steelwork. So we've got our ProSteel shapes. Within our shapes types, we have user shapes, roof and wall, combined, and welded shapes. Okay, we're going to run with standard. within standard, we can choose different shape catalogs from different countries. Okay, you can see I've got a couple of little stray ones have slipped in here. And what they do is the catalog then pushes through into our list of available ones. Okay, and then we can sort them into a specific order that we'd use them if we want to, just by using these little buttons. Okay, they push through into our shape class here then. Okay, so it just makes it neater, and the more common ones that I use come up the top. So I'm going to set the universal beam. I'm going to choose a size. Okay, 310, it's in my key. You can see the material grade is locked. I'm going to leave the configuration file as that's the color or level. Okay, part family, detail, style, display class, etc. Leave all in blank. I do not do them at this point. I do them much later. The other thing to watch out for, make sure your turn and your length is 0. Okay, that way it will default to whatever I nominate and whatever I put in. What we have here is our insert or reference points. Okay, and this big one here, that one there, okay, is the center of gravity. Okay. All right. We have numerous ways that we can put these little guys in. Okay, we can put them in by a line that we created, sort of like the work frame. Okay, we can just pick a line on the work frame and in it goes. All right, that's all very simple. We can put it in also by 2 point, okay, where we nominate the start and we nominate the finish. Okay, both are very simple, both very effective. If you didn't have a work frame, you'd use the 2 point. Okay, there's no real constraints to where we put steel. Now, one of the things I've got to remind you of is read the prompt line. Enter the start point. Okay, for 2 point, if we're picking by line, identify the line. It will constantly prompt you for what it wants you to do. Okay, learn to look down the bottom there. The next thing that catches a lot of people out is they try and make changes within here while the command is still live. We need to finish this command. So if I change these shape sizes or shape types or anything, you can see the shape updates. Okay, it is constantly live until we finalize the command. Okay, even if we change the insert point, you can see that it will change the way the object works. It's constantly live, so it's critical that we OK the command to tell it we're finished. All right. Okay, let's discuss the element coordinate system. All right, so I'll get rid of these. Actually, we'll grab one of these. And just to make it nice and easy for you to see, because the element coordinate system is a little bit hard to see while it's in the transparent modeling. There we go. Now the white's a little bit hard on the eyes, but you can sort of see the colors there. All right, this is the element coordinate system, and it is critical to the way that this object projects in a 2D environment. Okay, so this is the element coordinate system. Okay, element or entity. Okay, in a 2D environment, we have the X and the Y of the object. Okay, the red line points in the X-axis, the Y points in the Y-axis. The yellow is the extruded length, okay, of the object. And there's a little ball at the 0 point, or the datum of how the object was created. This is critical for how the thing is going to present in a 2D environment. If you were to model this in and you had that blue line pointing down, your object is going to detail upside down. Okay, so it's really critical that we're aware of how it is going to be set out. And I suggest that for a little while, till you get the hang of this, you probably print this little sheet out. Now, for as important as the ECS is, so is the insert or reference point for all of our objects, because this actually tells the software where our dimension points are located at. Okay, so for a vertical member, such as a column or a post or a door opening or something like that, we want it central. That's where it's going to dimension everything to. It's going to be center of column to grid, etc., etc. PFC, center back face of the opening. That's where we want it dimensioned to. For a horizontal member, top of steel. Okay, it's all quite logical. Okay, once you have a look at it, but nothing else will make more impact on your ProSteel detailing than following these few little steps. Okay, so I suggest you print this one out as well, and see if you can follow these steps. So let's get back to our model environment. Okay, we'll get rid of this one, and what I'm going to do is I'm going to summarize, I guess, what we've just been through. All right, so I want to get rid of this white background, but I'll leave it wireframe just for now. So I'll just put a background on. This will look a bit funky, but just go with it. It'll make things a little bit easier to see. So I'm just going to put a horizontal shape in. Horizontal will be top of steel. I'm going to just go 2 point because I'm going in space here. Start point, and don't forget to read down there, down on the command line there. Okay, we either accept or reset to rotate. I'm going to accept it. Okay, and you can see the blue line points up, which means this is going to detail correctly. The ECS, the ball, states where my start point is. The yellow line represents the length that was extruded along. This would be the negative direction out to the left, and my red will show us the front of the object. Okay? Absolutely critical to how it tells us how every object has been created. Okay, you can see that we have these little grips here, and we can just pull it. It will only ever go in the direction it has been initially created in. Okay? One of the things that I have a few people that get stuck with is they tick this disable handle by accident. Okay? And you can see here, once I hover over the object, there is no handle. It's just going to move. Okay? So if you get that, just have a look for that disable handle. You might have hit it by accident. All right? So you can snap to something out off the side of your model. Okay? It'll only ever drag the way it was created. It's lovely to use. All right? Now, personally, transparent modeling is where I prefer to be, okay? And it's a little bit harder to see the ECS, but you will get used to it, all right? So let's see if we can, I guess, follow the steps now of placing some steel in here. Okay, I'll show you the two different methods, all right? So I've got a vertical member, so the insert point instantly is, the insert point is the mid, and I'm going to go by 2 point initially. I always go bottom to top, okay? So 2 point, and we're going to practice some of our funky snap tips. I could snap it to the corner there, but I get really worried that it's going to pick the wrong thing if I've got lines over lines over lines. So what I want to do is I want to come away, hover over the line of the grid, and you can see that I've got an implied snap there, left and right mouse button together. I have my tentative snap, accept. Up the top. Okay, you don't want that one. You want the implied snap, so pull it back a little bit. Okay, so we get the implied snap, tentative, left and right together, accept. Okay, you want to get good at that, which is why I went through. Now, accept or reset. Reset is right mouse, remember? So if I want to rotate that, I want to right mouse click, and it will just keep rotating. Simple as that. Okay, now a little bit hard to see my ECS, okay, but I can tell you that the red line, you can see it there if you hover over it, that's the red line coming out. You will get the hang of where these are, okay, which means the blue line is going off to the right. Okay, start point, end point, rotate. It's absolutely simple. Okay, so I'm going implied, tentative, accept, implied, tentative, accept. Super simple, okay? And it just takes a little bit of practice. You'll get really quick at it, all right? Alternatively, we could insert by line, okay? We have got a workframe here. The workframe makes it really nice and easy to do this kind of work. We don't always have a workframe, which is why the 2 point is also very important, okay? So also don't forget, okay it before you make any changes, because remember, everything updates. Hey, don't forget to okay it. An alternative is this switch here. That means it breaks the current command. It accepts all the current changes, okay, and it allows you to make any changes, any additional changes now. Okay, so that will not now update. Okay, so there's a good little trick for you. So it's going to ask me now, see, identify the line. and I just pick the line, rotate, accept, pick the line, rotate, accept. Super simple. Okay. Now, if we make a mistake, look, I've got one here that I forgot to rotate, just like the work frame before. Select, right click, hold down, not right click, hold down the right mouse button, PS properties. Okay. These are the shape properties for this object. Okay, so we can change the layout, which is how it presents. I'll come in here so you can see it. Okay, so I can have it just a center line of an object. I could have it just a square box. The edges outside, edges inside is standard. With arcs, okay, that puts the real arc. That is exactly how the object is created. Okay, and by US Sketch as well. Right, edges inside is standard. It's nice and light on the resources. Here's that ECS switch. Okay, on older versions it wasn't on. We could also turn the center line on, center of gravity, pitch lines for holes, all sorts of stuff. Okay, in here we can change the shape type, the shape class, the shape size, the shape type. Okay, fully customizable. Okay, you can change everything on the fly. All right, in here in particular is the rotation and layout of the object. So at the moment, my ECS 0 datum should have been down the bottom because we went bottom to top, right? Okay, if I did something wrong and I wanted to flip it up the other end, here is the flip switch. Okay, and you can just flip it up the other end so that the 0 is now up the other end. Here it is up here. See? We don't want it like that. Obviously, we want it all the same, every column the same. Okay, we can flip things by a rotational angle. So if we wanted something other than 90 degrees, like let's say 5 degrees, these switches here will go plus and minus 5 degrees. These guys here will go plus and minus 90. Simple as that. Okay, so we can change everything about our object on the fly. Okay, so don't worry, if you put something in wrong, we can change it. The final thing I'll show you while we're in here, okay, is this is the part name, okay, and the material grade is in here. All right, all the data for this object at the moment is here. All right, the length, the mass, etc. Okay, and as we do more modifications and so forth to that object, we're going to get a bigger and bigger and bigger list within here. Okay. All right. The final thing, actually, while I'm here, let me just show you. I could actually make a tapered beam that's cut. Oh, I went a bit crazy here. Let's reduce that back to something a little bit more realistic. Let's go 20 mil taper. There we go. So you can see it's cut the beam. I need to go a bit more than that. 50. Just see if I can get that to okay. So you can see you can actually have tapered beams and everything. All right. Does a lovely job. Okay, we'll put our horizontal in. Remember, if we want it horizontal, so I'm going to go 310, I'm going to go the same size, must be top of steel, and I'm just going to do it quickly now. So let's pop in our beams. Simple as that. So I'm select, accept, because I don't need to rotate. So it's just left click, left click. All right, if the beam goes full length, actually, let me show you a different way we could do this again. There's lots of different ways that we can insert steel. So what I'm going to do is I'm going to move the ACS. All right, this would be the UCS, for example, in AutoCAD, but this is ACS. I'm going to set the ACS at the level that I want my steel at. So I'm going to move it up to this RL. Okay, it's still flat. All right, I'm going to go back to my steel. and I'm going to say I want beams top of steel, okay, and select the beam switch, and I'm going to draw a rectangle or a perimeter that the beams must fall within. Okay, how cool is that? All right, only works if you've got all the same size steel. All right, otherwise you're going to have to run around and update it. All right. Now, remember that handle I showed you before? Remember I said you can snap to other things. So if I snapped right up here or right down here, okay, it's only going to drag in the direction it was created in. All right. Really simple. All right. To be honest with you, even though I showed you the rectangle before, I'm going to put some smaller beams up the top. Even though I showed you the rectangle before, it's not normally how I'd put steel in. How I normally put steel in is like this. So I just select, accept, select, accept, select, accept. Okay. To be honest with you, that's how I do mine. All right. We just put a lot of steel in there very quickly. Okay. So I hope you have a bit of fun with that. You can see how important the snap control is, okay, within here with your tentative snap, etc., and how important it is to practice that. All right, I'll see you for the next session, which will be part 4.